Okay, so I was just experimenting with ChatGPT. So hi guys, welcome to High Entropy. It's day 57 of DSA learning. Today I'm starting very late, so it is the time to stream to learn uh, AI. But right now I'm starting with DSA. So first I will solve one DSA problem, then I will jump to AI. And today I don't know what happened, but my stomach is not good. Maybe I uh, might get urged to poop and I have to go. I don't know what's wrong with. Okay, by the way, welcome to Entropy and let's start DSA solving. So, here is the DSA problems without wasting time. Let me see once everything is working or not. Okay, so that we can start. I know the timing is very bad. Yeah, if you wanted, you would like to join. Please join. And I'm sharing in my Discord server. So if you have anything like you wanted to share, you wanted to learn along, you can join together. You can connect with me. And why don't we if you wanted, you would like DSA learning. Please join. And I'm sharing in my Discord server. So copy, share the link, never expire, and why I'm not keeping it along. Oh, so sorry. You can so yeah, if you wanted to join, you can join it, and we can schedule. Maybe if you let's learn together. If you are solving DSA problem, it's better like we'll connect and we can solve together because I feel like I'm solving alone. So if we can solve as a co-learner and we can solve same problems. Maybe if soon once I'll finish this driver sheet, I'm planning to start with lead code. There we can solve together. And because I saw one person's video, one person was teaching him like, okay, this is the way, this is so they were solving lead code contest. So I felt okay, this is very good thing. Like I wasn't like I was aware of this Discord, but I never used it. Then I watched 15-minute tutorial. I got the basics of it. So it's a kind of, you can think like a server means you are creating a channel inside Discord, and in the server you can create multiple components, maybe few text channel, uh, and and also you can create video audio channels, and you can connect one on one, or maybe you can connect multiple people. So it's like team, right? Teams. So I felt like okay, this is best way. If you we can utilize it in a proper way. It's great, man. So whenever you feel like if you wanted to join my channel, if you have your own, let me know. I will join there, no problem. It's just we are here to explore and learn, so no problem. Thanks, and let me start jump to DSA. So TP, today I'm little late or very late. So I was working on couple of things, and because of that, even today I wasn't I forgotten it. Like I was about to prepare for like I was about to start the stream for AI. I thought maybe everything is done. So thanks to God that he taught me like, okay, you are going to broke your streak if you won't do it. Oh, what the heck? I mean, I thought my streak got broken. So do you know what I did? I just solved the problem. So I need to create an alarm, set up an alarm like almost around 11 p.m. so that it will ring before 12 o'clock, so that if I'm anywhere, then I can jump and solve at least one problem. So this is the problem that we are going to solve. Okay, so here when I click, it's not the right place. DP20, I think it's a standard problem, that's why it is showing DP20. Okay, let me see first problem. I always have a habit of, this is the solution that I just copied from there. I just to keep my streak because I was sure like I will be late and I forget and streak will be broken because I'm learning, right? And obviously I'm solving it every day, so that's smart. So let's see minimum coins we need. The title of problem: given an integer array of coins representing coins of different denominations and an integer amount representing a total amount of money. Denomination means I mean one coin of 1, 2, 3. I think I solved this problem. And okay, given these coins representing coins of different denominations. Okay, okay. So all the elements will be different. Okay. Add an integer amount representing total amount of money. Okay. Return the fewest number of coins that are needed to make up that amount. If that amount of money cannot be made up by any combination of coins, return -1. There are infinite number of coins of each type. Oh, oh, okay. It's not like one. So definitely every coin has maximum options, like you can take that coin multiple times. Ah, okay. So it is like unbounded knapsack. I know, but I think I forgotten how to solve it. So let's see. First approach. Else I will watch the video if I. Okay, no. Let's first try it. I think I solved it in the past, but I'm not. I'm not sure like how to solve it. What I see 125. So it means you can take the same coin many times until you get the number. So it's not like you have a limit. Okay, so our goal is to find the minimum number of coins we and get target amount. Looks cool. Okay. 1 2 3 amount 11. 1 2 3 amount 11. So you can start with, okay, let's see, 1 2 3 2 5, and another one is 2 5, and AMT equals to 3. So let's start with this one. So first thing is, like, we will start, every coin has two options: take or not take. Okay. So first we'll start with 1. At starting we have 0 back in the amount. Then what you have, options 1 2 3, or let's start with 1. I say like, okay, I will take 1, so the amount will be 1. You will say I won't take 1. Then what are the remaining options? You have 2 and 3. So you will say okay, then you have 0 right now in the level 1. Here you just said. Now you have two options again. Either you can take 1, because 1 can be taken again. So you will say, okay, let me take 1 again. And here you say, I won't take 1. So this one and this one, like here, it is same condition. You are at the same level. You won't take. Now you have 2 and 3 option. Here you will say, okay, I will take 1 again, and you will say, okay, no problem, you can take 1 now. Okay, sorry, my bad. It will become 2, it will become 3. So here you will say 2 I took, I won't take 1. Now if you won't take 1, then what are the options you have available right now? 2 and 3. So you will be having 2. So now you have, like, here if you see, you have 0 amount and you are having 2 elements, 2 and 3. So can you make, here you have 1 total, and target, you can say, you are right now you have current value 1 and you have option 2 and 3. Here you will say 2 and 2 and 3. So you see, these are the things that are Okay, here also you can see if you are not taking one, then you won't take it back, right? Only the thing is, so here you will say when I am taking 4, so you will say okay, these are, so you can go up to 11, and you will not take, then you will say, let's say explore another one. So let's say here we got option up to, simply we got 11, and you will say okay, I got 11, then this is one option available, so you will say okay. And here let's say this will be 10, so from 10 you won't, you say okay, I won't take one. So now what is the options, you are not taking one, so you have option 2 and 3. So 10, now you have, if you are not taking anything, okay, you haven't take this, then you will be having 10. Now you will take 2, and you will not take 2, so 10, 12, 12. And if you will take, if you will not take, then it will remain 10. And what are the options you have? Now options you have 3, so you'll say okay, then again 3 you will take, and you will not take, then it will be 10. And now you don't have anything option remaining, so you filled out, you took all the coins and you are not getting, so that means you won't get anything. Hmm. Okay, so here you will say okay, 13, 10 plus 13, so you will say not possible, 12 not possible, that's how you will say. So we, what I'm thinking, so first thing is like denominations we have 1 2 3, so we need to think about memorization, right? So at each point you will be either at any particular position, like if you are here, so you have options to take or not take. If you are here and you will say look it, let me take again, so if you are take, if you are at take means you will remain here, and not take, you will move to I plus 1, that means you cannot take the previous elements. And if you are moving here, suppose you are here, that means you already discarded this element, that's why you got to here. Or one more condition is possible. Okay, so yeah, always that will be the case, either you are, you haven't taken it, or you are unable to take it. There are two options, this weight is higher, so you cannot take it, or something. So basically you cannot take previous element, that's why, so you need to jump into another, let's see if you can make it possible. Looking good. So every time you have either n options, not n. So only thing is how I'm going to memorize it. Memorization. First let's think about it. Recursion I got. So every time what I'll do, okay, let's first write the recursion, so I'll get more insight from it. So at each stage you will say what is my I, location, which denomination you are picking up, which coin you are checking. So it could be 0 1 up to n. So let's see the constraints first. What are the constraints here? So n number of distinct denominations can be 100. Coin of I, 10 to the power 3. So what will be the maximum recursion depth? You are considering the same coin each time. So 10 to the power 4, 3. No. And amount can be coins of I and amount. So amount can be up to 10 to the power 4, 3. So it could be like you are going till 10 to the power 3 into 10 to the power 4 to 10 to the power 5. So it could be maximum recursion depth. If you are going one by one, so let's say you have 100 and your amount is something and you are taking and n is 1, then 1 1 1 1 1, and then you will say 10 to the power 3 you can go up to recursion depth. I'm just trying to analyze. So 10 to the power 3, but every time you will say again you will explore. So you can say 10 to the power 3 and each time you have 3 options. So what will be? It will be exponential. And I'm not able to. Oh, hold on. Let's first solve it. I can be 0 and it could be, it's basically representing the coin that you are picking for denomination coin, or coin number that you are choosing or not choosing. And then, so this is one thing. Okay, so I can be go up to n, from 0 up to n minus 1, I mean. And let's assume memory we have something, and then what will say, if current value, yeah, current, what is the current, what is target, and then you can say array you are giving, that is for denomination. So right now you are giving this. If okay, one more thing, I mean, yeah, denomination what we are getting, that is also possible, right? Right now at starting you will be having 0. So let's say we'll add one more parameter, denomination. So denomination will, not denomination, coin count. So let's say CC. CC means coin count. So we'll keep it here, CC. Okay, starting will be 0. So if current value, current is greater than equals to, not greater than equals to target, it means you got the result, right? So you will say return CC coin count. Okay, if you can say I became, you are already covered all the coins, now you are not getting, that means you haven't got the target. I became greater than equals to n. So okay, we need n as well, that will be the length of number of coins. So return -1. Okay, so from here you will get -1. If CC, okay, so these are the two options. Now forget about the memoization first, so it will be like placeholder for memoization. And now the thing is what we are going to do. So we got the result. Now there are two options, take and not take. Okay, so if you are taking, take will be equals to -1 at starting, it's similar to other one. And what I will do then, if adding the current value, I mean the current target value amount is not exceeding the value. If it is exceeding, then definitely we cannot add it into the bucket. So we need to discard it. We cannot take it further. So if current plus area of I less than equals to target, right? If it is target, then you will say take equals to and function I plus 1, not I plus 1, it will remain same. In another option it was like always you are progressing, but here and current plus area of I and all other stuff will be cc don't forget, cc means coin count, cc plus 1 and all of this thing. And not take, that means you are choosing another option, that will be function, you are not taking it, right? So I plus 1, current will remain current, coin count will remain coin count, and all other stuff will remain this. And finally you will say, okay, one thing remember, here you will take, if min of these two, then definitely you will get minus 1. So what we'll do, okay, let's make result. Result is nothing but initially okay, so if take equals to minus 1, then return simply not take. Okay, else if it is not minus 1, if not take equals to minus 1, return take. Else simply, and I'm using some stupid return min of, that means both of them are not minus. I'm just thinking if any one of them is minus 1. Okay, let me do simplify. I got it. If take or not, okay, take equals to minus 1 or not take equals to minus 1, any one of them is minus 1, then return max of, definitely the one that is having value, take not take. This is simpler. Else what you do, that means both of them are not minus 1, so return min of take not take. I like the way I thought to improvise it, and it's happy. Now only thing is so you will say we are looking for something like I at particular and current value. Okay, these are the two options. I can go, if you see, I can go up to 0, 1, 2, n minus 1, right? And current means target value can go up to 10 to the power 3, so it could be 0, okay, it can be not can be 0, but here we will take 0, 0, 1, 2, because 2, okay, up to amount. Okay, got it. Now every time what you'll do, you will say everything will be minus 1, Whenever you have value something, that means, okay, one more thing I'm thinking about. -1 if I'll keep if I'll keep -1, oh, that means it will be something you can think of like, okay, it could be result, right? -1, so we cannot keep -1. Okay, so what else you can do? Let's say INF plus INF I can see there, so that's why I'm in the screen. So I thought let's not take INF. If it is INF, that means this value is already max. Okay, so if it is INF, that means you have to, it's not been filled yet, so you need to calculate it. Other than that, if you have any other value, you'll say okay, we need to calculate it. So we can fill this value with array. So let me solve it. What is the time right now? I mean, I forgot to. What is time? 26 minutes already passed, bro. What the heck are you doing? 1-7. So what I'm thinking, is anyone joining? Join my Discord server if you are watching. As did we see? I don't think. No problem. No problem. No problem. If anyone is gonna join, let me know. Join my Discord server if you are watching. So why I'm not, no one is joining. Okay, no problem. Define solve, and we are going to say I is representing the CC current count. Okay, first thing is self variable I key CC, and then let's say n. Is there anything? Array, memory. So I think I have covered everything. So array will be coins, will be replaced with coins. Memory, I hope I covered everything, right? So if let's say memory first, so n will be nothing but len of coins, and why do you forget the amount? Without amount, no way to get the result. So let's say, so so memory, let's say memory only, for float INF for underscore in range amount +1 for underscore in range, you can say n. 0 to n -1, you will say okay, great. For let's say memory you have created, now you have two options. Okay, return self dot solve 0 0 and amount n coins mem. Okay, if cc equals to amount, not cc. I mean I forgot one more variable current coin, current value. So it will be 0 as well. Current. So if current will become amount, that means you have got the value, target value. So you'll say okay, no problem. If I got the value, then I'll say cc equals to current equals to amount. Then you will say return cc whatever is count we got, coin count. else another thing is like if I became greater than equals to n, that means you covered all the coins. Now still you are not able to find the value. So return -1. And if mem of you can say okay, I and current and the coin that you have is greater than equals to, is not equals to float of, oh god, where are you going bro, float of I enough. If that is not the case, that means you have some value. So return mem of I and current. Okay, now just say this one, take equals to -1, and if current plus, if you are adding the coins of I less than equals to top amount, that means you can get it. Take will, you will say okay, no problem, self dot solve I will be I, remain I, cc will be cc plus 1, current will become current plus coins of I, you added the coin, and amount will remain same, n will remain same, coins will remain same, memory will remain same, and then not take is equals to self, and just let's copy it and just modify it. CC, you are not considering this, the coin denomination won't be counted, you are not adding anything, so definitely it won't be there. Finally, if take equals to -1 or not take equals to -1, then that means 1 is -1, so you can take max of both. So return max of take, not take, else, that means both of them are not -1, so return mean of take, not take, and yeah, it should be result, not result equals to let's say result equals to -1. And finally you will say, what you will say, you will say okay, result mem of I and current value is equals to result, return result. I was about, oh great, I got it done. Line 15, maximum recursion depth exceeded in comparison. Current equals to amount, okay. Still, oh my god, I'm so sorry, I plus 1 it will be. I thought something went wrong. We need minimum, right? So I'm getting minimum 1 2 3, like I'm getting 7. So what are the options that are available? 1, you can say 5, 5, 10 plus 1, 3. I got 7 here in the second option. Okay, it's like and 5, 7. You are not getting the result and it's returning the value. No problem, let's do it. So initial value is 0. If current value became CC current now why dump charade. What is it? Dump charade. Dump charade. Dump charade. Oh. Dump charades. Dump charades. Dumb charades. Dumb charades, popularly known as dumb charades. What I'm doing. Okay, let's say I equals to, it will start with 0. It will say either it will say consider it or not consider it. If current amount equals to now if I greater than equals to n greater than minus 1, current amount became greater than amount, that means greater than minus 1. Coins memory. No, I'm clueless, man. I'm just thinking like how should I debug it? Mount plus one coins and range. If I'll start debugging it, I will die. Result equals to minus one. Take not take. Oh, here is the van. Please start with one. It will consider. Then it will consider 1 to 111. Another branch will consider 1, and after that in the next run it won't consider 1, so it will consider 2, and the next one it will consider 5. Let me print take not take. What I'm getting, just wanted to for I, let me say I and current. What I'm getting, bro, it's a very bad way to debug. I do not see any options. For 2 then, 0 1 2. So what I'm thinking, like I have 1 2 5. No, what is 1 2 5, and target is 11. So 5 1 2 5. So I'm looking at the 0. I mean 2. What are the different options at 2? 2. If we are looking for 10. 2. It could be like 1. You will consider 1. Then you haven't considered 2. Bro, I'm just saying. 5 you considered, 5 you consider. So 1, I mean what we are printing? I current. So I will be 2 0 1 2. 2 and current will be 1. 2 1, where is 2 1? 217. Kashra somewhere I made mistake. And now I will do, if I'll debug, I will die. Literally, I0 return current equals to amount. And current value plus coins adding, this is less than this one. Then what you did, you will keep I in the same location. And you are looking for a different one. It's DP options, not I'm looking for that one. Debug it. Let's do it, man. I do not have any options. Whatever I have written, I just made some mistake or what? Okay, let's compare the code better. Is there a modulo to take? God. What they are doing? I know only one tariqa and I'm applying, but I'm 124. I don't think today I will be able to do that. How it's possible? 50 minutes, God. Okay, let's assume you are starting from first line, and let's do one thing. I equals to 0, CC equals to, I think it will take ages if I'll do this, like current equals to 0 and empty we have current equals to amount, current equals to amount, whatever the value cc we have will return. If I became greater than n, that means all the points we have already checked, minus 1. Current greater than amount, take not take minus. Two two four 6 5 9. Clueless. Should I watch the video? if I'll watch the video, then I will won't get what exactly problem is in my solution, and I don't want to debug it like manually by trying recursion, but I don't have any options else. So it will be like you are at 0 and you have 0 and current value 0. So now you are at 0, then you will do one thing, current, and this will be no I CC current. Let's do it, man. I do not have any options. So we are going to follow these things. You take, not take. Okay. So let me say, if I will take 1, 2, 5, I am at 0, 0, 1, 2. So if I will take, always left side take, not take. So if I'll take, then it will be something like, and our goal is to I and current. So 0, 0. So that means, okay, let me take. So I take, so it will become 0. I will remain at 0 and it will become 1 and current will be 1. Right. And again, it will be like 0, you will be 1, you will be 2, you will be 1. Currency will become 2. I mean current value will become 2. And so on, and you will go up to 0 and you can say 11. Count will be 11 and values will be 11. So we'll get 11 from this side, and here let me draw one more thing. Let's say this is like the condition, and here you have 0, here you are at 10 and you have coin 10. So now what you'll do, you got 11 from this side and you will move to another side. So you are not taking this. Now you have option 0. I mean not you are not at 0, you are 1 and you having amount 10 and you are looking for currency 10. I mean your amount is 10, you are looking for, your count is 10, you are at first element. Now you will say okay, now you will say okay, no problem, I have two options, take or not take. So you haven't taken the one, so you will say okay, no problem, still. So you have 2, you are at 2, now 1, at 1, now you have take or not take. So you will say okay, I will take it. So if you will take it, then it will become 1, 12, and what is CC, right? CC. So it will become 11 and 12. So that's not possible. So you will say okay, I won't take it. If I won't take 2, then you will go to 1, 2 and 10. You still have 10 and you are in the 2 because you haven't taken it. So coin will be, number of coins will be 10 and 10 will be the denomination. Now take or not take. So if you are taking, then it will become 10 plus 2, 13, 2. Okay, if you are taking, then you have 2, 11 and 10 plus 5, 15. So it won't be possible. So you will say okay, not taking, that means you will be 2 10 and 3. You will move to 3. So this is also not possible, so you will say -1. So from here you got 11, from here you will return 11. Now next move will be something like this. So you took 1. Now you are not taking 1, so you will be having, you will move to 1 and you have now hmm, not here, you will move to I mean, still I'm confused. What should I do? Shall I ask ChatGPT? Will it help me? Haven't they created any chat application? How to fix it? Debug it. My mind is dividing into two parts. Means it says like okay, continue. Second, it says like you are doing something dumb. But let me do it, man. I don't know. Maybe I will be able to solve one option, but I will get something from it. So let's say 1. We are at 1. Actually, I need to explore a lot of options then. It will be like you are going to here, you are not taking, then you will be at 1 and the amount will be 0. It will be somewhere here. Like you have 1, now not taking any further, so it will be 1 and 1 and 1. Now again you are not taking 2, so even I think it's difficult for me to draw the tree. So I'm doing some mistake, blender mistake. Let me use ChatGPT now. I feel like, but I know if I use ChatGPT, I won't get anything from this thing. Let me once more. I wanted to see my brain is working. Float. You took something. You took something. You did this something. Print I CC current at each step. Let's see now. Zero zero. ICC ICC current and to take, not take. Result it's print. Pro. It's better. Still, my heart wants it like solved using ChatGPT. So let me drop it. I will feel bad, very bad. I never trying to solve using ChatGPT because it won't help me anyhow. So still, my inner self is denying me to solve it using ChatGPT because I'm not here to make record or something. I'm here to learn something. And if I will use it, definitely it won't help me. But God, I'm doing somewhere by me.
So today we will be solving the problem DP. Assume the target is given at the minimum number of coins required. Now you might be saying, Striver, this is very simple. We are just gonna take the target and whichever is the maximum value, we divide by it like greedy way. Like the first approach, so maybe like we can definitely solve this using greedy. So if it was greedy, it would have been like, okay, these are the array elements, and the target required is 7. Pick up the biggest coin, which is 3. Can I have it? Yes, it divides it by twice. So I can have two denominations of coin 3, right? And what is the leftover part? 7 minus 2 denomination of 3, which is 7 minus 6, leftover is 1. Which is the next biggest coin? 2. Can it divide? No, 0 denominations of 2. Which is the next biggest coin? 1. Can it divide? Yes, 1 denomination of 1. And after this, 1 minus 1 denomination of 1 will be 0 left. So you'll be like, okay, I'll require 2 coins here, 1 coin here, which sums up to give me 3 coins. Greedy does work for this test case, but it might fail. So can we figure a test case where greedy fails? Assume I give you something like 9, 6, 5, 1. Okay. And these are the denomination of coins. And I'm looking for a target of 11. Okay. I'm looking for a target of 11. So will this fail? If you apply greedy, the biggest coin is 9, and you'll be like 11 by 9, 1 denomination of 9, leftover is 2, 6 cannot be applied, 5 cannot be applied, 1 can be applied twice. So you'll be like, I'll be requiring 3 coins in order to form the target of 11. But actually, if you pick 6 and 5, the requirement of coins will be 2. And we saw that if we follow the greedy method, it does fail. Again, why? Same reason, uniformity. There is no uniformity there, right? There's a 9, but it might happen the next couple of elements might be something which gives you better values. So uniformity is not there. Like if you 9 to 6 difference is 3, 6 to 5 difference is 1, 1 to 5 difference is 4. But there is no uniformity in the differences of coin. Thereby you don't know what is the next denomination. Hence, something like greedy cannot be applied in such cases. And that's when we think of what? Trying out all combos to form target. And this is something which we have done in which problem? Knapsack. Over there we had to figure out the maximum value. Over here we have to figure out what is the minimum count. Right? So try out all the combos and take the combo that has minimum coins. Take the combo that has minimum coins. Right? So the problem is to figure out minimum coins. So what is the rule? What is the standard rule to write the recurrence? And how do you try out all combos? There's only one way. That is if you write the recurrence or recursion, and then you can think of DP, tabulation, and everything. So rules. Do you remember the rules, guys? I've been teaching that forever. Now, what are the rules? First rule is express the recurrence in terms of first is index, and obviously you're looking to form something. In the knapsack also you hand up back. Over here also you're looking for a target. So the second recurrence will be target, which I can call it as T, right? Then express, yes, then express. Third, you have to take the minimal of all, right? You have to take the minimal of all because over here the question clearly states, find out how many minimum coins will you require. So what is the question stating? The question is stating to find out the minimum coins, correct? So can I say I have to write a function that returns the minimal coin? So if I'm writing n minus 1 and target, so that means if there is an array like this, yes, if there is an array like this, where this is 0 and this is n minus 1, I'm saying till n minus 1, till the entire array, what are the minimum coins that will be required to form this target? This will tell me, is it 2, is it 3, is it 4, is it 5? What are the minimum coins? This f will tell me. Whatever is the question, that is what the f generally resembles. So this f is going to tell me what are the minimum number of coins that you'll be requiring to form the target. And for this portion of the array, n minus 1 means the array ends over here. So I can start easily. Okay, so let's write the recurrence now. So we have an index, okay, and we have a target. So let's forget about the base case and what did we learn about this express all possibilities? Generally in subsequences, there are two possibilities. Either you take the coin You take the coin or you do not take the coin. But over here, there will be slight difference. Let's understand why. So if you carefully see, whenever we took the coin 3, we used two additions of that, right? We used two additions of that. So the question states there is an infinite supply of coins. In the previous questions, a single element was just used once. Like in the knapsack, what you did was you stored, if you steal or stole whatever, an element, you just store it once. But over here, this denomination can be used once, twice, thrice, as many times as possible, right? And you might be thinking, Striver, then the best thing is divide it. Like if you're using it, do a 7 by 3, they're using it twice, 8 twice. Will that make sense? No, because it might happen. You don't need always, like, assume there's something like 25. 25 by 3 is 8 times. You don't need to use it 8 times. Probably there might be a case where you just have to take 7 denominations of 3, make it 21, and then probably take 2 denominations and make it 25. There might be cases like this. It's always not necessary that if you're using a denomination, you end up using the entire portion. I will again repeat. Assume there was a target of 25 and the denomination is 3. It does not necessarily means that if you're taking the denomination of 3, you take 8 denominations of 3. It can be 7 denominations, it can be 6 denominations, it can be 5 denominations, it can be any number of denominations that you can. Make sense? So I'll be like, okay, there can be two cases. One is I decide I will not take. That's for sure. And if I not take, am I adding to the number of coins? Because the function, what is the duty of the function? To return the number of coins. So make sure when you're not taking, you count the number of coins. So the number of coins counted will be 0. And if you're not taking it, what happens to this f? You had an array, right? You probably are standing over here, and this is your portion. And if you do not take it, you have to move back. So please move back. So when you move back, it will be index -1 and target. Perfect. And what about take? So if you're taking, right? If you're taking, now you're looking for minimum. If you remember, I told you, whenever you're looking for maximum, assign everything to int mean so that it's not considered. Whenever you're looking for minimum, assign everything to int max so that it is not considered. So if you're taking it, make sure take is considered as int max. Okay, now when can you take it? So this array, you are at this index, and assume this was 6, and the target is 3. Can you take this denomination? Will it make sense to take this denomination? The answer is no, because if you take a denomination of 6, but you're looking for a target of 3, so it does not make sense. So before taking any denomination, just make sure you ask, does the coin at that index is lesser than the target that I'm looking for? If it is, then I can take it. Now if you're taking a coin into your denomination, let's understand. If you're taking a coin, what is this function doing? This function is counting coins. This function is counting coins. So how many coins are you taking? 1. And rest, for the remaining target you have to figure out, right? For the remaining target is t minus coins of index. Because if you took up a coin, if this is the array and there was 3 and the target was 8, so if you took this 3, this 8 will reduce to 5 now. That's what I'm doing over here. This 8 will reduce to 5. And now you look for what are the minimum in which I can form this 5. That's why you'll again call this function choice. You'll again call this function by taking it. But there's a question. What will happen to this index? Because if this 3 is picked only once, you add 1. But if you go back, you will not be allowed to pick it once more. So the best thing that you do is you say, I'm going to stand over here itself. Yes, I'm going to stand over here itself. And I'm going to pick it again. So I will call the index again, and this time it reduced. So basically what I did was, if there was a 3 and the target was 8, so I was looking, what are the minimum number of ways in which I can form 8 in this portion of the array. Now, if I picked up once, this will be 5. I'll again look in this array, in how many ways can I form 5? That's my motive, that's my thinking. Make sense? So what I did was, I stayed at the same index. Remember, this is a thumb rule. Whenever there is an infinite supply of anything, infinite supply, multiple use, such statements, whenever there is infinite supply, multiple use, such statements, always when you consider take, it will stand at the same index. It won't move to the previous index. It will stand at the same index. Now you might have a question, but Striver, if it stands at the same index, it will keep standing. No. First it was 8 when you picked up 3. Next it will become 5 when you pick up 3. Next this 5 will become 2. And then you cannot pick up this 3. Hence, ultimately you'll move. You will move at a moment, because by picking up, you're reducing this target, you're reducing the target as much as possible. So eventually you will move. So that's the funda of take. You always stand at the index. Remember this. Whenever there is something like infinite supply, something like multiple use, you always will stand at the same. To return not take is what in the report that. How do you write these cases? At the last, a single array containing a single element and a possible target. So this is an array at index 0 and possibly containing a value 6 and a target 7. Now tell me one thing, if this is containing a value 6 and a target 7, can this target be achieved? Like, what are the minimum number of coins? If I ask you, what are the minimum number of coins that you will take this coins that you will take in order to achieve this target? Sir, now your answer is, if I change the target to be probably, but the minimum steps will be counted as 0. Don't return 0. So let's write down the base case. So the base case will be very simple. If index is equal to 0, and then you'll have to write something. So I know, and we are always assuming these cases. the coins will always have a denomination of greater than 0, because there will never be a denomination of coins like that. That's common sense. So if array of I, or rather, if target modulo array of I is equal to 0, we will return what? We return target by A of I, because that's the minimal that we will require. Or else, there is, like, we cannot form
What
it.
do
We will require. It will always have a. So let's write down the base case. So the base case will be very simple. If index is equal to 0, and then you'll have to write something. So I know, and we are always assuming these cases that the coins will always have a denomination of greater than 0, because there will never be a denomination of coins like that. That's common sense. So if array of I, or rather, if target modulo array of I is equal to 0, we will return what? We return target by A of I, because that's the minimal that we will require. Or else, there is, like, we cannot form it. We will return int max. That is how you can easily do this stuff, right? And just to make sure that it is no overflow, probably you can return something as 1e9. Again, why? Because see, you're adding 1 plus 1 plus, if any of the function gives int max, it will be 1e9. Like, if any of the
internet not working or what? Oh god, I'm just thinking. My solution is also the same, right? It is wrong. I know I can reduce the number of variable, but still, I believe I'm missing some corner cases. If current equals to amount, coin count return. I mean, literally, what I did, bro. Now it will. If I will try to sleep, I won't be able to sleep. Okay, so one thing I found. I mean, I just need to. I think one thing I found. If current not equals to it will be 7 only. I mean, I'm just doing some mere mistake on. I know my brain so stupid. Say 210 minus 1 you got, and it's like Right now you have. Okay, let me just try to debug it. So you are at 110, 10. First you are at 210, 10. Bro, let's solve it. You are at 210. Your value is 10. You have 10. And you return 10. So 2 is the. You are at 2, you will 10, 10. You are not at 1. You are at 1 and your value is 10. Okay, let's do one thing. It's not helping me. Let me think about tabulation method. Fuck self. So everything is funny. Let me do one thing. I'm confused. I will take help from ChatGPT. Fuck off. I don't care. Now I just want to understand. But there is a fundamental issue with your memoization. Okay. If I'll remove, then also it won't impact, right? Let's say I don't need it for the timing. CC I can manage from here. If the current amount it become. Okay, let me think from another angle then. It means you can return 0, right? You don't need any any further coin count. You already got the count. Minus 1. Okay, now what I'll do? So, return self.solve. Current. Let's say if I'm adding 1 plus, if not adding 0 plus, will it change the result? I don't think so. Coin change. My dimag is smoking up, my brain smoking up around the same thing. What is time right now? 2:05. Okay, bro. I think it's not. It's better if I'll stop streaming and I will jump into the AI. It's better I will do it tomorrow again. No problem. God. Let me rethink about it. Maybe later. So sad. Bye bye. Let's jump into another AI. I need to go through at least 1 hour.